Hi, in this video we are going to talk about simple algorithms, specifically one simple algorithm. Now the reason for this video is we identified um, that this is a problem area, okay, based on your examination scripts last term, that a lot of you guys have difficulty thinking of how to do a basic thing, such as finding out the largest or the smallest from a list of items. Okay, so the objective here is to understand a simple way to identify the largest or smallest element in the list or in an array list. Okay, this is probably the most familiar kind of list which you have been exposed to so far. Now, think about scenario. You are actually given a series of items, let's say circles. You are given a series of circles of differing radii. Okay, some are bigger, some are smaller. Of course, this is an unsorted list, and this is at position 0, position 1, 2, 3, 4, 5, 6, 7, 8, 9. So you are given 10 circles of differing radii in the form of an array list, for example. And your problem is to identify the circle which is the biggest. That means the one with the largest radius, or the circle with the smallest radius. Okay, let's think about, let's say the problem here. Given a list of circles, find the smallest. So how do you approach this problem? I'm going to give you a commonly used solution. It's probably one of the easiest solutions. So you will start by checking the first circle. You go down the list sequentially. You check the first one, you move on to the second one, move on to the third one, all the way to the last circle. So if it's a long list, you have to go through every circle in the long list. So when you look at the first circle, you have to you just assume that it is the smallest, and you keep track of the smallest radius so far. Okay, and you keep track of the value as well as the smallest circle so far. Okay, now the first circle will be treated as the smallest circle so far with the smallest radius so far. Okay, and I moved to the second circle in the list and I check if the second circle has a smaller radius. If so, the second circle becomes the smallest circle so far, and the smallest radius will be updated with the smaller value. Then I move on to the third circle and I'll check the radius of the third circle against the smallest radius so far. Let's assume that circle 2 has a larger radius. So I'm going to ignore circle number 2, that means the third circle. Move on to the next circle. I'll check the radius. Now this time the radius is smaller than the smallest radius so far. So circle number 3, or the fourth circle, becomes the smallest circle so far, and the smallest radius so far will be replaced by circle number 3's actual radius value. So we go down the list one by one. We use these two variables to keep track of which is the smallest circle or smallest radius which we've encountered so far. So by the time we go through every circle and we reach past the last circle, the value stored here and the value stored here should reflect the smallest circle and the smallest radius. Of course, this smallest radius belongs to the smallest circle. So this is one very commonly used approach. Some people will want to start from the back to the front, although there's no good reason to do that. People always start from the front to the back. Okay, so try not to do something strange when this strange thing does not add value to your solution. In this case, there's no difference whether you want to start from the front or the back. Okay, so I changed this into program a programmatic problem. So there is a main method here, and I've created an array list of circles, and I've created the circles and added them into this array list called circles. 1, 2, 3, 4, 5, 6, 7. There are 7 circle objects, and they're all added into the array list circles. Then I'm going to call this method called getSmallestCircle. I pass in an array list, and this method is expected to return the address of the smallest circle in circles. I will then store it in this variable called smallest and print out its radius. Okay, if getSmallestCircle has been correctly written and returns the correct circle object, line 15 should print 1 because this is the smallest circle. So the challenge now is to write this method called getSmallestCircle, which takes in an array list of circle objects and which returns a circle object. This circle object is the one with the smallest radius in the array list. Okay, so I've just written some pseudocode to depict the idea which I've just talked about. Set current smallest r, the smallest radius is to be the largest possible value. Hold on, I should be doing this to the now there are two approaches. The first approach is to two common approaches. Set it to the largest possible integer value. Okay, and if you are not familiar with the Java 7, I should be searching for Java 7. With the integer class, okay, the integer class has got a final constant called max value. The actual value is 2 to the power of 31 minus 1. It's a huge, huge value. It's the maximum possible value that can be stored in an int. Okay, so I'm going to use that. Largest possible integer value is integer dot max underscore value. Okay, whatever that value is. And I'll set the current smallest circle to null. This is of type circle. And I'll loop for X number of circles in the list. So if there are 1000 circles in circles, I'll go from the first to the last. And I'll check if the current circle, the radius is bigger than smaller than the current smallest radius, I'll update these two values, okay, to reflect the current circle. And then I'll go on to the second circle and check again, go on to a third circle and check again, and so on and so on. After I've checked the last circle, I'll just return the address of the current smallest circle. Now this is one approach whereby I set the current smallest radius to the power of 31 minus 1. The second approach was what I mentioned just now. You just set it to the first circle radius, first circle's address, and then I repeat from the second to the last circle, the loop. Okay, now the assumption here is of course there must be at least one circle in the array list which is taken in. Otherwise, you probably want to return null. It's not mentioned in the question. So perhaps you may want to check if the number of circles in circles is, let's say, 0. Okay, immediately return null. Alright, so this is the strategy. This is one way to solve the problem. Let me change this into Java code. Okay, I'm going to pause the video now and change everything. Okay, I'm continuing with the recording now. What I've done is I've converted my pseudocode into actual real source code which compiles. So I have this method called get smallest circle. I'll check circles.size. If it's 0, I'll just return now straight away. Um, and then I have these two variables, right? Current smallest circle, which is the first circle, and current smallest r, which is the radius of the first circle. Assuming there's a getter called getR, which returns the radius. And then there's a loop here. Now a loop starts from the second circle, where I is 1, and we'll go all the way until the last circle has been, checked. So in the loop, current will store the address of the current circle being checked. In this case, circles.get1, which is the second circle. Now we'll check if current.getR, the radius of the current circle, is smaller than my current smallest radius, then I'll replace the values in current smallest r and current smallest circle. Okay, and this will carry on until the last circle has been checked, by which time I'll expect the current smallest circle with this variable to store the address of the smallest circle in the whole array list. And then I reach line 35 and I return the value stored in current smallest circle, which is the address of the smallest circle in the whole list. If the list contains only one circle, that's the address of the first circle, because in that case, I won't even go into the for loop at all. And I'll return to line 14. Smallest will, the returned address will be stored in smallest, and I print out smallest.getR. Now I've tried to run this program, and there seems to be no problem. It managed to identify that 1 is the radius of the smallest circle, which is the case if you look at this data here. Alright,